Hey pre-calculus. In this video I'm going to be doing 5.3 day 2, factoring and solving with identities. So sometimes when we're solving, it's not as simple as the other problems we were doing in my last video. So when your trig functions cannot be combined, on one side of an equation, try factoring and applying the zero product property. So let me show you what I mean with an example. So let's say we have 2 times sine squared of x plus sine of x equals 1. And we know that x is an element on the interval 0 to 2 pi. And I'm going to do hard brackets for both. Okay, so when we look here, if we were trying to solve, like, you might think, okay, we'll move the sine over, but then I still have a sine squared. So this is the same case when we're solving for x, right? If this were x squared plus x plus a constant, you would hopefully be thinking quadratic. So what we're going to do is we're going to move the 1 over and use what we know about quadratics to solve this. So that means start by setting it equal to 0. And then what we're going to do is we're going to let u equal sine of x. So I'm going to replace all of my sines of x's with a u, just to make it look a little bit more like a quadratic. And then I'll go back later. So now this is a little bit easier to solve. I'm going to solve this by using factoring by grouping. So remember, you do your little, either do this in your head or you can do little x on the side for scrap work. So we do a times c, which is 2 times negative 1, and b, which is 1. So what multiplies to negative 2 and adds to be positive 1? And that's going to be 2 and negative 1. And we take these two numbers and we're going to replace them here. So I have 2u squared plus 2u minus u minus 1 equals 0. And then you separate it into 2 groups. So this is my first group, here's my second group. I'm going to factor out the greatest common factor. So the greatest common factor here is 2u. And I'm left with u plus 1. And here the greatest common factor is going to be negative 1, because we don't want a u to be negative or variable here. So I'm going to factor out that negative, and we're going to be left with positive u plus 1, which is perfect, because then we have a u plus 1 in common. So we can factor that out, and we have u plus 1 times 2u minus 1. And now I can use the zero product property and also switch it back to sine. So this isn't u plus 1, it's sine of x plus 1. And this isn't 2u minus 1, it's 2 sine of x minus 1. So now I use the zero product property, and then it's like the problems that we did the other day. So sine of x plus 1 equals 0. 2 sine of x minus 1 equals 0. So here, sine of x equals negative 1. And here, sine of x will equal, I'm going to add 1 and divide by 2, so it'll equal positive 1/2. And now we're going to think of our unit circle. Okay, what values, right, will give us, so sine of what angle will give us negative 1? But remember, it's between 0 and 2 pi, so that only actually occurs once when x is 3 pi over 2. And then for this, when is our y value 1/2? That occurs twice between 0 and 2 pi. It occurs at pi over 6, and again at 5 pi over 6. And that's it, because they're just positive and negative, right? If they were plus or minus, that'd be a different story. Okay, so we're going to do one more example. Before we do, you can also use the trig identities along with algebraic methods to solve for trig equations. So let's give you a second example. 1 minus cosine of x equals 2 sine squared of x, and x is an element on the interval 0 to 2 pi again, and I'm going to keep it hard brackets. We'll include the 0 and 2 pi. So now this one's also very different than the two types of problems we've done, because we have cosine and we have sine, right? And we want to solve for x, and in order to solve for x, we're going to likely need these to be the same, especially since this is squared, right? So you might think, okay, we'll factoring. We can't factor if these are two different trig functions. So what we're going to do first is what we know about Pythagorean identities. So we've just been proving a ton. And hopefully you're looking at the sine squared and you're like, you know what? I could rewrite that in terms of cosine. How? Pythagorean identity, right? So sine squared of x is equal to 1 minus cosine squared of x. You remember your Pythagorean identities. And now everything's now in cosine, so what I'm going to do is I'm going to simplify this, and then I'm going to go back to what I did up here, and I'm going to factor. So I'm going to start by distributing this 2, so I get 2 minus 2 cosine squared of x. And then I'm going to move everything to one side, and I want my x squared, or my u squared when I eventually use u substitution, to be positive. So I'm going to move this to the left, and I'm going to rewrite it in the appropriate order. So it'll be 2 cosine squared of x, and then we have a negative cosine x, so just minus cosine x. There's nothing to combine with it. Sorry, my pen's getting upset at me. And then I have 1, and I'm going to subtract 2, so that means it'll now be negative 1 equals 0. Now I've got a quadratic, so what I'm going to do is use my u substitution. You should be defining u somewhere, so I'm going to let u equal cosine of x, and I'm going to rewrite this as 2u squared minus u minus 1. Yeah, and then I'm going to factor by grouping. So what multiplies to negative 2 and adds to negative 1? That's going to be negative 2 and positive 1 this time. So 2u squared minus 2u plus u minus 1 equals 0. Make sure we have the equals sign. We've got an equation the whole time. So factoring by grouping, I've got a greatest common factor of 2u. And here, greatest common factor is just 1. But when you do factor by grouping, you do want to factor out something. So that now we have 2 of the same factors, so I can factor out a u minus 1 and 2u plus 1. But as we know, these u's actually represent cosine. I'm just going to jump to setting them equal to 0 using the zero product property. So this is going to be cosine of x minus 1 equals 0. And this is going to be 2 times cosine of x plus 1 equals 0. So that means cosine of x is going to equal positive 1, and cosine of x is going to equal negative 1/2. So I'm asking myself, okay, when I think of the unit circle, what x values, right, because it's cosine, has a value of 1. That occurs twice within this interval, right? It happens at 0 and it happens at 2 pi, and because these are hard brackets, they're both going to be answers. And then for negative 1/2, this also occurs twice. It's negative 1/2, so that's going to be in quadrants 2 and 3. So we have 2 pi over 3 and 4 pi over 3. And those are my 4 answers. So it's just important to remember your algebraic skills. Use substitution can be really helpful, and sometimes you're going to need to use your trig identities as well. And obviously you need to make sure you remember the unit circle so you can figure out your answers.